Calculate the time required for a 3,000 Newton force to stop a 912 kilogram car initially traveling at 35 meters per second. So we have a car moving at 35 meters per second. Now there's a certain momentum associated with that car, right? That car has a momentum. Remember, that's how hard it is. The momentum is how difficult it is to bring that object to a rest. So that's what we're trying to do. We're trying to bring this object to a rest using a 3,000 Newton force. Now, that 3,000 Newton force isn't going to be enough to stop it in the blink of an eye. It's going to take a little bit of time. And what we're trying to find out is how much time it's going to take if we keep applying that force to bring that object to a halt. Right? If we bring that object's velocity down to zero. In other words, if we bring that object's momentum down to zero. So really what we're getting at here is impulse, a change in an object's momentum, right? Remember, that's what impulse is. Impulse equals change in momentum. And impulse is also equal to the net force times time. So what we need to do is find the change in momentum and the time it takes for that net force to change that momentum entirely. So the change in momentum, remember, is equal to mass times the change in velocity. So let's plug in what we know for that. Change in momentum, we know mass is 912 kilograms. We know the change in velocity, if we're changing it, we're bringing it from 35 to 0, our change in velocity would be 35. Technically, it would be negative 35. So let's write that in there. Actually, let's not worry about that because we're going to get time in the end if we don't want a negative time. So 35 meters per second. We're going to change it by that much because we started off at this and we want to bring it all the way down to 0. So we need to change it by 35. So let's first find that. 912 times 35. And that winds up giving us 31,920 kilograms times meters per second. So that's our change in momentum. Well, now we need to use that. We need to use change in momentum. That's too big. That marker is way too big. We need to use change in momentum is equal to F net times time. Change in momentum we said was 31,920 kilograms times meters per second. That's equal to net force, which is 3,000 newtons, times time. So divide both sides by 3,000, and you wind up getting time is equal to 10.64 seconds.